Architecture Meeting. GNUU Service Landscape.
I'm your host Frank. Hello and welcome to the meeting Architecture GNU Services Landscape. GNU stands for Germany Net UUCP, a service invented in the 1990s from one of the first internet service provider in Germany, Germany Net. UUCP is much older and a shortcut for Unix to Unix copy, an internet service before regular email services reached the masses, and the internet is full meshed like today. In the past, the nodes were only partly online, or you must call the server, for which you have data, for example email messages, and send them packed batches. The extra protocol UUCP was reinvented later by Ian Taylor, so you can use UUCP over TCP. That means you don't need a modem anymore and you can call the other side over the normal internet with TCP protocol port 540. So there is some old stuff and some historical. Here's a picture of the first version of UUCP Germany Net. x86 PC with SUSE Linux provided UUCP service to Germany Net customer and a gateway to email services and the Usenet. At the end you have the kind of batches, email batches from your email communication with the world, and news batches from your subscribed news groups out of the Usenet. Further mention a different packer like gzip, bzip, szip, compress, and different batch times and sizes are part of the configuration. The commercial service was retired and an independent foundation was found, GNU e.V. The foundation is more a legal thing to spread responsibility and costs to the members. GNU lives further on dedicated servers to rent. Here's a portal where you can compare prices. A good dedicated Linux server starts from €20 per month up to 40 or 50. Remember, we have a service from the last century, so the hardware requirements are on a minimum level. At least for your comfort, you look for a server with a hardware rate, for example. A lone server movement is almost a mess, because there are so many things you have to think about. So in 2020 I came up with the idea to move from bare metal servers installation to virtualize and step up. Let's see how cloud native is UUCP and use Kubernetes service. At first to move to Kubernetes you need Kubernetes. I started to look around for managed Kubernetes services on a budget level from €20 per month. As you can read in this blog, it's much more expensive also on the basic level. Google Cloud, AWS, Azure, the prices are between 80 and €150 per month for the services, which is mostly one worker node, plus extra costs for storage, for network, IP addresses. It's too much. By the way, blog Almeter contains interesting stuff about Kubernetes and OpenStack. Lots of tutorials and blogs and entry level if you want to start with Kubernetes. Most in German, but some articles are also translated in English. Check it out. At the end of the research, I came close to K3S Kubernetes service from Ranger. Normally you have at least 3 master nodes for Kubernetes plus worker nodes for your workload. In K3S you have this all-in-one. It's Kubernetes service for edge computing. Come on, our services are already on the edge, so it meets perfectly. K3S has a one-line installer. We start on a plain Ubuntu machine like Ubuntu 2004. With Kubernetes you can manage containers. What we need more is storage. So we have Open EBS service here, and fantastic open source project for provide different persistent volumes claims to Kubernetes, mostly in HA installation as distributed versions, but for our one server there's also a OpenEBS standalone storage class. By the way, K3S has its own local storage class. Alone with OpenEBS we are able to back up the storage to S3. Other main components are traffic and ingress, load balancer, controller as part of K3S, cert manager to manage Let's Encrypt certificates for our services. And of course, MySQL is today easy to install in cloud native. There are many ways in deployments, Helm charts, MySQL operator. We have only a small database and the Helm chart out of the box is enough for us. Let's have a look closer to the GNUU services. Here starts the interesting part, the integration of apps in Kubernetes. In the past we had a bunch of Perl CGI scripts to provide web functionality for configuration and account management. These scripts are rolled out with Puppet in a Puppet module during a Puppet manifest, as you can see here. What we talk about is the configuration for your site in the UUCP agent. There are some web formulas where you configure news groups, the batch sizes, the packer, and the email configuration with your domains. The web service is divided in a static part with few or no changes. This content is hosted on GitHub, fetched by nginx bot on startup and served to an internal service, then ingress service to the world. Main features are here the internal Kubernetes load balancer mechanism, the traffic ingress controller and the cert manager, which provides this beautiful Let's Encrypt SSL certificate. The interactive part of the web server is now realized in Python Flask. Flask is very common and holds many main features like web formulas, as you have seen here, or template handling, MySQL connection and this URI routing, like here. The main function of this Python program is to store information in the MySQL database. In the past we had a cron job every minute to write this information from the database to config files. Now we have a job API triggered after the configuration change from the user on the web UI. Another Python app is called here to write the UUCP sysconfig, for example. This file generates in the same script Kubernetes config map files, and we have kube API access in each pod to a service, and at the end we can create the config maps in the same program. Config maps are mounted to the services pods for news, UUCP and mail, or copied to the pod. In news, for example, we merge our news server configuration with the static news configuration from the software package. By the way, some parts of the used software are not maintained anymore, or there was never a maintainer for the package, like for szip packer, or the batch SMTP mailer, BSMTP. For this reason, we have another web server called repo, where these packages are built and hosted. By the way, we built our own Docker images. Based on Ubuntu image, the mentioned packages from the UUCP repo are copied here, special scripts for UUCP and mail delivery copied in and hosted on Docker Hub. The first time we built also the images there, but this took too much time. Better place is GitHub Action. There are various actions on the marketplace also for build Docker images. It's very fast. I think it's an unknown service, but it's good. What you really want to know in CI/CD is the status. Was my build successful? Was the service restart after a new Docker build? GitHub Action has also the possibility to start a kubectl task and make a rollout restart on the specific application, so check them out. Okay, let's talk about communication on this place. In the past, we had different mailing lists provided by mailmen, gated to internal news groups. Traffic count was between 2 or 5 messages per year. For real-time communication, like foundation meetings, we used an Ajax web chat, which works not pretty well. In research, I found Matrix.org, a decentralized encrypted chat platform. Elements is a web client service formerly known as Riot, where you can run your own Matrix chip in a container in Kubernetes with an API and ingress and Let's Encrypt. Can read would love it. So, we have the Matrix server with channels for team communication, but also a Matrix bot service. This service has 2 API endpoints. One is a specific Docker Hub webhook with callback service if a new image was pushed in the configured repo. Second is a web service where you can trigger the bot to send messages to a specific channel. GitHub provides also this webhook push events where a commit will announce to the channel. Check them out. But that are all development and helper tools. Call back to the main application. Normally we would separate each application with each function to a separate service. That's cloud native, but there are 2 things with a dependency. rnews. This program will call from the UUCP server program UX to send news articles to the news server. Maybe there's a remote option. Can't figure out, so UUCP and news must be run on the same pod. rmail, the same thing with email. Unpacked UUCP batches are piped to rmail to deliver email. We separated mail on this extra service, but this works only for incoming email. By the way, email use and UUCP are not part of the Ingress service. We use host network in Kubernetes and direct access to the node port. This is not too critical, but you should have an eye for security reasons. For example, running pods in non-root security context. Easy to separate is the Gray listing service, a Perl script which provides an TCP service where postfix can loop the emails and delay them for anti-spam reasons. We have a pod for them and an internal service endpoint. That's it for the current state of the project. We have some open tasks after migration, security hardening as mentioned, testing out the S3 backup backend on OpenVPS and restore, monitoring. Some tests are done with Prometheus and Grafana, which is pretty good for cluster monitoring. More interesting would be application monitoring, which is maybe also possible with Prometheus, but this needs some work. Scale out nodes or cluster. Interesting tool is kubefed for Kubernetes federation, so check them out. We are an open community with an open development. You can find all our code on github.com/GNUU-DE and Matrix channel GNU-talk matrix.org. If you have further ideas and Kubernetes use cases in this context, let us know. We are looking forward for new foundation members and new members of the development team. Cheers, Frank, and out.